Hello everybody, welcome back. This is lesson 8 of unit 11. This is the second to last video of this unit. There will not be a lesson 10 video. Lesson 10 is the case study, and that will kind of act as an end of unit assessment, so make sure you are trying your best on that. Just to kind of give you heads up on dates. It's not mentioned on this slide yet, but just so you're aware, make sure you are following the schedule. Friday, because today is Wednesday that you're watching this, I believe. So Friday, the Unit 11 review Cathode learning will be due, and then the following Monday, the case study is due on Google Classroom. Okay, so there's this video. Tomorrow's video will go over Regents questions, going over the 2 types of electrolytic cells, and then there is no video for the case study. You just have to read and do it. So, let's jump into this. It makes the most sense for you to have the note sheet that says electrolytic cells out and follow along with this video. So I want to go over what they are and kind of how they differ from voltaic cells. So up until now we've talked about voltaic cells. Today is the last part of the new stuff. Okay, so here are pictures of a voltaic cell and an electrolytic cell. So this is voltaic. It has a voltmeter, so that's where voltaic comes from. You might also see it as galvanic, because why not give everything 500 names? And then this one is called electrolytic. So take a second, look at some similarities, some differences. That's kind of up to you. One thing I do want to point out though is the battery that the electrolytic cell has. That's that required outside force that it needs. So remember we had talked about how voltaic cells are spontaneous. They can kind of happen on their own. Once this switch is shut and the circuit's connected, it just goes. Electrolytic, on the other hand, if you connect a piece of metal to a spoon, wow, you've connected a metal to a piece of spoon. Nothing happens. You need that battery to kind of get stuff moving. That's what makes it non-spontaneous. So any other similarities and differences you find, congratulations. Let's just jump into notes. So in electrolytic cells, these reactions do not occur spontaneously. So you need that extra outside force to get it started. So in other words, you need that electrical energy, which comes from the battery, to kind of get things going, and it takes that electrical energy and converts it into chemical energy. So it needs electrical energy to kind of be able to do chem-related stuff. So when electricity is being used to force a chemical reaction, the process is called electrolysis. So that's where electrolytic comes from. So if we think about this word, electro means electric, and then lysis is to break apart. So when we're talking about electrolysis, it means you're using electricity to break things up. And since we're talking about chem, we're breaking up compounds by using electricity. So electrolytic cells, even though there is only one container, they still have both the cathode and the anode. They both have cathodes and anodes. I forgot which one I said first. So the cathode, because we're talking about cathodes right now, is where the electrons are sent. So electrons still move anode to cathode. That is consistent amongst both types of electrochemical cells. Now it's important to remember there are some differences, and we'll kind of put together the similarities and differences at the end, but electrons always move anode to cathode. So where it's different is that the negative electrode is the cathode. So in a voltaic cell, so let's just go back to this picture. Doesn't help because I don't know which is which. Never mind. So in a voltaic cell, so what we spent the past 2 days on, the cathode is positive. And so it means the anode will be negative, and that kind of makes sense because the electron, if you're negative, you have more electrons. So the electrons move from the negative side to the positive side. Think of like diffusion osmosis going from high concentration to low concentration. So something that is negative, the anode, is able to give away its electrons to something that's less negative or more positive, the cathode. But in electrolytic cells, it's the opposite. So this is one of the main differences. Now, the cathode is negative. So here you'll see the battery, and you have a plus and a minus. So whatever side the minus is on, that's what makes it the cathode. Now with electrolytic cells, there'll generally be a strip of metal and then a weird object like a key or a spoon. So we'll talk about these uses of electrolytic cells, but this is kind of one way you'll notice that it's electrolytic. Now, reduction still happens at the cathode, so red cat still makes sense. But the only thing right now that's different is that the cathode is negative. So what that means is this is why it is non-spontaneous. Electrons happily move from negative to positive. But in electrolytic, you want the electrons to move positive to negative. That's not what they're inclined to do. So you need to force these electrons from the positive side and move them to the negative side. You need to force them out from where they're happy and move them. In order to force them out, you need that extra input of energy, and that is what makes it non-spontaneous. So looking at the anode, that's this half of it. That's where the electrons are drawn away from. So again, electrons always move anode to cathode. That's not changing. The oxidation still happens at the anode, so NOx still makes sense. But again, now the anode is positive. And again, in order for the positive side to give away electrons it wants to hold on to, it needs that extra input of force. It needs that battery to kind of rip off the electrons from the positive side and dump them on the negative side. So a few quick uses. We had said that, again, electrolytic or electrolysis means like using electricity to break something up. So you can use it to break apart compounds. So an example is breaking up molten or melted salt, so in this case NaCl, and break it up into its two components. So not the ions, the actual solid sodium metal and the chlorine gas. You can also use it to break up water molecules and other stuff. One of the things you'll see most often is using it to electroplate something. So if you see like silver-plated spoons, silver-plated necklaces, gold-plated something, a metal-plated, they use this process to kind of do it. So they take, if you're electroplating something, that's what makes the object the cathode and the other thing the anode, because we're taking stuff from the anode and moving it to the cathode. So here's like some spoon. If you take this silver metal and you use the battery to rip off the electrons, it attaches themselves to the spoon, and now the spoon looks shiny silver. So again, the cathode is that random object, whether it be the spoon, the key, something that's being plated with another metal. So just kind of to wrap up and compare and contrast these two things. So if we're talking about voltaic or galvanic cells, again, those mean the same thing. And electrolytic cells, there are some similarities, there are some differences. So the flow of electrons, whether it's forced or spontaneous, a voltaic cell is spontaneous, meaning it happens on its own. Once that switch is connected and the circuit's complete, everything just moves. The electrolytic cell, again, is forced. Because you're moving from positive to negative, you need to force those electrons off and move them. So the positive electrode in voltaic cells, that is the cathode. In electrolytic, that is the anode. The negative electrode is the anode in the voltaic cell, and the cathode in the electrolytic cell. So these first three things That is where the differences occur. Everything else is the same. So electrons always flow anode to cathode. It doesn't matter what kind of cell, always anode to cathode. Reduction always happens at the cathode. So that is why red cat always works. Oxidation always happens at the anode. So NOx always works. Okay? So just to kind of go back a second, if we're talking about the mass of the anode and the cathode, we can say, well, this is the cathode, it's being plated. Again, the cathode is still increasing in mass. That's basically it for new stuff this unit. This was a pretty short video. That is it. There is nothing due tonight. Tomorrow there is an electrolytic CAS learning due. Friday you guys have the Unit 11 review due. And then Monday will be the case study. So I'll see you all tomorrow for the practice of electrochemical cells video. That is it. Have a wonderful day.